Everyone, welcome back to another video from Winter Forest. Today let's continue our leetcode challenge. Today's question is called Flatten a multi-level double linked list. So you are given a double linked list which indicates to the next and the previous pointers. It could have a child pointer which may or may not point to a separate double linked list. This child list may have one or more children of their own and so on to produce a multi-level data structure as shown in the example below. Flatten the list so that all the nodes appear in single level double linked list. You are given the head of the first level of the list. Here then, look at the first example. You will receive the head. Then expect the output is like this one. The structure it is like this. So what are we going to do? I just pre-draw. So here in what they moved, the action is he populated the load from 1. The legs is 2. 2 dot legs is 3, but the 3 have a child. So this done is the child. So the child have and then have a A9. The child A have a child 11. So I just published it in here. So for us to do we're going to loop in this one. And what we're going to do is, so we continue for the next. So if my pointer is in here, so why the head node is not now, then I'm looking for the, then I keep moving, push and moving, push this into the output, and push and move into here. Once we move to here, then we need a change because they expect, you see, from 1, 2, 3. First, need to go to the children. So go to the child is go to 7. I definitely need to go down. So I need to make sure I don't lose. Next time come back, finish the child. I need to come back to this load. So we are cut this load, give this dot next, push into the stack. So the stack we have a 4, 5, 6. Now, so push this in, head in. So this will be the head in, then we have all of this. And then it will be changed. Now the loads this one. So this one will be removed. Here it will be changed to this one. Instead like this. It will be 1, 2, and then 7. A. Move to 7 and A. Once we move to 7 and A, once we move to A, we found that A has child. So for this one, I cannot loop now. I need to push this into the stack. So in after this item, it will have another one. Then my stack have this 9, 10, and now. Then I don't have this one. Instead of this. So now your output is pushed into to here, to here. Now you have this. Once you finish it, I start from and stack. Then last in, first out. Then it move to 9, 10 until into the end. Then you pop another one. Then 4, 5, 6. Now. So if after try it is 9, 10. Afterwards, then is 4, 5, 6. So once you pop this out already in, you finish it, you meet now, then you pop the stack out, then you loop in this load until find the now. And since this be pop out, it remove from the stack. Now you go into this one, looping finish, find that now you go in pop this one out. You put 4, 5, and 6. Now your stack is empty and you finish it. So now you have your result. Push it. So this, when you looping push this into array, now we to write our code reflect this behavior. So we going to have a stack save. There is something we cannot the next. They not have a child, also have the next loads. We start with the head. In this head is not equal to now. We go into find the, we check has children or not. If they have children, then we need to push in the children into our stack. Because and if they have children but don't have legs, you directly just looping from the children. But if they have children also have the legs, then you push the children into the stack. So this t.legs is the children. In previous in here, if you looping to here and you have a child and you also have a legs, so this dot legs push into the stack. That is this code to. Once you push to the stack, then you t.legs will equal to t.child. Because t.legs are pushed into the stack, so t.legs replaced by the child. So actually you move here 7 to here, this into the stack, 4, 5, 6 already in the stack, and the 7, start 7, then push it into here. Once you push it in, then you continue looping for the child. Because you push it, then they in, so this called prev. Previous then will be the t, because the here t dot previous it is the 3, and now we're going to update this one to the head. So we start previous we start from here, now we start with this one. So the child since already push into the stack, so the child will be nullable. Then the t move to t dot next. Since you update the t from here, you move the t to here, the header into here. So now the t start with this dot left. T dot children dot previous equal to t. Yeah. Previous in here t dot child equal to now, t dot legs equal to t dot legs, so it is 7. And what happens if this t dot child don't have a child? This loss if don't have a child, then we need to see if have a legs. Then we continue looping with the t dot legs. So just like previous, if this t don't have a child, we just looping. So first I come in here, don't have a child, t dot legs, don't have a child, t dot legs. If t have a child, if t have a child, at the moment t is 3, if t has child, then we're going to see t dot legs, not now, That means I cannot need to save this one. So this one we are pushing the stack t, it is 3. T.lex equal to T.child. So now move the 7 up to here, to this position. This will be known. The 7 position will be the next instead of the child. And T.child and the previous, T.child is 7. The previous will be equal to T. So change the link. So this one move to here. So it is 7, 3 and 7. T.child now is now, and then continue T.next, then continue T.7.a. Now we come to here, T has child. Now you recycle this step. But if then have that's simple, just see if the next, if it's no next, also no child, just they have another condition. If not the next, then you need to see the stack is empty or not. If the stack is not empty, then just move to the stack. They are linked list, so any stack it is a lot. So you just pop up, then you just T.next, keep moving to this, pop out the value. Since this linked list, so you need to tell the next also need to link the previous, so double linked, so you need to update the next, also need to update the previous lot. Then you can move to the next lot. And if no child, no next, also stack already looping finished, it means you totally finish it. Then the last lots give T.empty, and then you head still the same. The T is the pointer in this case, so you still return the same head because you only moving around the pointer to change the pointer. Now let's run the code. T not equal to 960. To finish, just submit it. See if it's match any scenario. It accepted. Thank you for watching. Bye bye.